Thank you, Nico. Hi, everyone. I'm Kadi. I'm a developer at Expo. And wow, how great is it to have a React Native keynote at React Conf again? I feel really privileged to be here today at React's 10+1 birthday at that, to talk to you about building production-ready apps with React Native today. Now, you might have heard it said that building mobile apps is kind of hard, especially for developers coming to React Native from the web. You have higher expectations when it comes to developer experience, because you've lived it, you experienced it, you know how good it could be. And you want the same kind of experience when developing for other platforms. At Expo, we want to bring the React Native developer experience more in line with web dev. Let me show you some of the things that are tricky about native development. First, of course, we are targeting multiple native platforms in a single code base. This is what React Native is all about, allowing us to run React code on native iOS and Android platforms. Now, the really awesome thing about React Native is, of course, that React Native apps are real native apps. So when you create a text input using React Native, it's not secretly rendering it in HTML. It is using the real native text input components for each platform. This is so important for performance and the native look and feel of your app. But it does cause a difficulty for React Native developers. And this is that you need some way of surfacing all of these native functionality to the JavaScript side, so you could actually use it in React. So accessing the phone camera, sending push notifications, using Face ID, all of these and more require a native module that bridges this code from the native side and makes it available to the React code. Then we have navigation. Navigation on mobile comes with a ton of nuance and functionality that you don't see on the web. Remember how React Native apps are real native apps? Well, unfortunately, this does mean that you need to also manage some of that native code. You need to keep it up to date. And finally, there is actually building your native app, both for development and deployment. Building native apps is shockingly difficult compared to web dev, and it requires specific native dev tools and a security step called build signing. React Native lets us render React code on the native iOS and Android platforms, but doesn't help with the rest. Let me show you how using a React Native framework does. I am, of course, going to talk about Expo. Expo is a free and open source framework for building universal native apps with React Native. We also built the Expo application services, which is a set of cloud services built specifically for React Native and Expo apps. It is an optional extra which you can choose to use with or without building your app with Expo. The team at Expo have been a constant presence at the React Native community from its very inception. We really believe in the technology, and it's demonstrated by our decade-long commitment to it. For example, we were the first ever to publish we published the first ever React Native community libraries, only a couple of months after the initial release of React Native. We created React Native Directory, a place for searching and discovering React Native libraries. And we helped organize React Conf back in 2016. We also contributed to React Native directly, being the first external contributors to run a release of React Native. Among other things, we helped add async functions to React Native, and, as you heard from Ricardo earlier, collaborated with Meta to ship the new architecture to open source. And today, we are beyond excited that this has led to the creation of the first React Native framework. What React Native gives us out of the box is the ability to run React code on native iOS and Android platforms. A huge amount of work goes into making this happen. We have Metro for bundling, JSI for communicating between the native and JavaScript layers, Fabric, the native renderer, and of course, Hermes, the JavaScript runtime. And on top of this core functionality, React Native also ships with the most fundamental components, like your text, view, and text input. But the goal of React Native is not to provide access to every single native device capability out of the box. Instead, we are given the API and the mechanism to do it ourselves. And this brings us to the first hard thing about React Native development, and this is accessing these native capabilities. React Native provides the mechanism, but it does not actually expose all the functionality needed to build modern apps. Hence the reliance of community libraries. These are often from people and companies from the community who needed to use functionality from the native side didn't yet exist bindings for. Libraries for animation, maps, vision. And we have built many of these ourselves. And we pulled much of the fundamental functionality together into the Expo SDK, our extended standard library for React Native. It includes a huge amount of components and capabilities that are not included in React Native, but you usually need to build your production app. For example, the SDK includes libraries for common authentication patterns, one to facilitate browser-based OAuth flows, like login with Amazon, the all-important Apple Auth, and a library that lets you use biometrics like Face ID and fingerprint. There's Expo notifications for sending local and remote push notifications, and Expo sensors, which lets you access device sensors that measure motion, orientation, ambient light, and open the door for creating experiences like this one, a neat little game that uses your device orientation as controls. We rarely create libraries that are already included in React Native, but one exception to this is Expo Image, created mostly to provide better compatibility with other image libraries we have, and to support more image formats like SVG. But on top of supporting image formats, it also comes with easily configurable native transition animations. And you can even enable live text interaction on iOS with a single prop. So with these and other React Native modules readily available, you're likely to find an existing library that suits your needs. But if you don't, and you need to write some native code yourself, you'll probably want to use the Expo Modules API, which is built on top of the React Native JSI layer. Now, I know the idea of writing native code may seem a bit daunting if you primarily write JavaScript, and to be honest, it very much was, back when your only options were Objective-C and Java. But the Expo Modules API, in the Expo Modules API, the native code is actually written in Swift and Kotlin. So it tends to feel surprisingly approachable for TypeScript developers. To get started, you can use this npx command to create a new module. And this will create a new project with everything set up ready to be released to NPM. Or you can use the local flag, set it up to use in a private project. In the module, you'll have a place for your native Android, iOS, and web code, as well as an example app ready to set up for testing. Here is an example of a Hello World module where we call a function to receive a greeting from the native code, with implementations for web, Android, and iOS. Then in your React Native code, you can call a single function or your native module and render the platform-specific greeting for each platform. So you can use the Expo Modules API to build additional native capabilities for your own app, or join others in the community who are already using it to share open source libraries. So to access native capabilities, things not already shipped with React Native, we have the libraries in the Expo SDK, plus many community libraries which account for almost any need. And if you do need to build a new native module, you'll have the Expo Modules API. Next on our list is navigation. On the web, you might be used to building your own navigation UIs from scratch. On mobile, users have certain expectations about how the navigation should work. There's a lot of subtle behavior that makes building your own UI completely from scratch a very difficult challenge and something you're likely to get wrong. Let me show you what I mean. Here's the Conf app on Android and iOS. Has everyone downloaded it? Well, there's still time if you want to do that. We're still on day 2, so you can try it out. Try some of the things I'm going to talk about out for yourself. So this app has a bottom tabs layout, a UI pattern that's very much expected on mobile. There's a subtle UX expectation even on the bottom tabs that you might not even realize that you and your users have. Like when I scroll down, oh, did I do that? Like when I scroll down on the home page and then tap on the home page tab bar, the screen auto-scrolls to the top. Let's look at navigation between screens. On Android, the Talk Details page slides in from the left, and to go back, we use the swipe left gesture to go back. On iOS, the screen opens in a modal with an iOS-specific animation, and we actually close the modal with a swipe down gesture. So not only are we adding gesture to the mix now, we also need to support different UX for Android and iOS. Let's look at another example. Let's use the search on the speakers page. On Android, we tap the search icon to start typing. Whereas on iOS, we scroll down to reveal the search input. This is just some of the expected behavior from a navigation system on mobile. There's a lot of platform-specific expectation that would be pretty overwhelming if you try to build it from scratch. So really, you'd probably want to use a navigation library where all of these things are already set up. Our solution to this is Expo Router, which brings file system-based routing to React Native. I'm sure most of you are already familiar with file system-based routing, as there are several frameworks and established patterns already on the web. Let me show you how we made this work in React Native. Here we have a stack navigator with 2 screens and a button to navigate between them. With Expo Router's file system-based navigation, all of your app routes are defined in the app folder. The key to making this work on native is the layout file, which is how we organize the screens and declare how they should be rendered, as tabs, a modal, or in this case, a stack. Notice that I didn't need to list out any of the routes in a stack, and that's because this information is implicit from the file system. You only ever need to define them if you want to add additional properties such as header icons, styling, or in this case, a title for the screen. So with Expo Router, you can create truly native navigation experience for Android and iOS. Not only that, but you can also target the web. That's right. In the same code base, you can build for iOS, Android, web, and even tvOS. And this makes code sharing between all the platforms a real possibility. Furthermore, we've recently added API routes to Expo Router. For React Native, this is beyond exciting, because for the first time ever, we have an easy way to write server-side code inside our React Native code base. So for navigation, you could use Expo Router. It provides a native navigation system that works beautifully on iOS, Android, and web, and tvOS. Next up, we have the native code. I think I pressed this twice. Next up, there's the native code. Although with React Native, we're building applications primarily with JavaScript, we still need to occasionally handle some native code. There are some things that can't be done without it, even with a library, such as changing the app name and icons. And of course, we have the dreaded upgrade React Native experience. With Expo, we have a solution for this, and honestly, it eliminates at least half of what I used to find frustrating as a React Native developer. It's called Continuous Native Generation, or CNG, because who doesn't love an acronym? Let's see how it works. This is the structure of a React Native project. We have our source folder for your JavaScript code, and the iOS and Android folders for the native code for each platform. And this is another folder structure of another React Native project that uses CNG. This is also an Expo Router project, so we have our app folder for our file system-based routing, and our component folder for the rest of our components, and not a native folder in sight. And that's because this project is using CNG, Continuous Native Generation, to generate these folders. The idea behind CNG is that native code can be generated from a set of inputs, making it ephemeral. I mean, anyone here checking their node modules to Git, for safekeeping? No? Chances are you don't. Chances are you're going to install your node modules based off your package.json and your log file using npm or yarn. So in a similar way, you can run npx expo prebuild to generate the native projects based off of your app.json and package.json. Note that this is not in any way a lock-in. You can always opt out of using this workflow and manage your native folders directly. But let me show you why you might want to use CNG. Who here hasn't heard someone complain about the React Native upgrade experience? I mean, it's basically a running joke in the community at this point, and for a good reason. Recall that React Native includes all these wonderful tools that make React code work for iOS and Android. Well, all this code lives inside the iOS and Android folders. And I think you might already see the problem here. If you check these folders into Git, and then you make additional changes on top for your own project needs, it means that there is no way to automatically, reliably upgrade to a newer version of React Native. You need to do it manually. And I mean really manually. There are tools like the upgrade helper that show you the diff between your current version and the version you want to upgrade to, and you go through every single file and manually copy them into your code base. Who here has done that? Too many times. Even with a CLI tool that adds this diff automatically file by file, you're still left to oversee each merge and resolve the complex. Painful indeed. Compare this with how you'd upgrade a React Native project that uses CNG with a single CLI command. You install the newer version of React Native and simply regenerate your native folders with pre-build. Other than upgrades, a huge benefit of CNG is that all of your app config is defined in a single file, in your app config file. Now, I don't know about you, but the first thing I do when I start working on a new app is create the app icon. I used to do the same when I did web dev. New website, adding a favicon, top of the to-do list. It just makes the thing you're building more real and exciting. God, that's better. There, the app icon is updated. Doesn't this instantly feel so much more like a real app? And here's the change I actually made in my app.json. And here are all the changes that were generated automatically because my project is using pre-build. You can also extend pre-build with config plugins. Config plugins are basically little JavaScript functions that allow you to edit files in the native directories during pre-build. So you could write your own config plugins or use config plugins that are shipped with libraries. So for example, we used the React Native boot splash config plugin to configure the library for the confab splash screen. If our app didn't use CNG, we would have had to follow the instructions in the README to manually edit some of the files in the Android folder. But with CNG, we only need to add a plugin to our plugins array. So to better manage the native code in your app, you can generate it dynamically using continuous native generation, and use config plugins for any additional changes. Now, let's move on to the last and perhaps the most difficult part of native development, and that is the native builds and deployments. What do we actually need to do to get an app from your local machine to run on your phone? First, we need to have our build environment set up. That's not too dissimilar from web dev at a glance, where you need to have your node and your NPM and such. But to build native apps, you also need some special tooling. So Android Studio for Android and Xcode for iOS. There is already some nuance here, such as you also need to install and set up Java for Android Studio, and Xcode, you can only get it if you have a Mac. Next, we also need to sign builds. Build signing is necessary for any native apps, and without it, your phone actually won't let you install it. So for Android builds, you need to create a key store. This is actually not too hard, and you can create one anytime on your local machine on Windows, Linux, or macOS. On iOS is where things get a bit tricky. You need a provisioning profile and a sign certificate. These are tied to your app ID and also contain information about capabilities that your app is allowed to use, so you need to keep them up to date. There's even more nuance to it, but suffice it to say, it's complicated. And this brings us, and this is exactly what we want to improve with EAS. EAS is a cloud service that helps you build, develop, and deploy React Native apps with ease. It bears repeating here that you can use the Expo open source framework without using EAS. And everything you can do with EAS, you can do without. It just might take you a little bit more work to set up and maintain. The main two things that EAS wants to achieve is to allow you to develop native apps without needing the native development environment set up. And secondly, we want to handle the hardest parts of native app development, which is the credentials management. With EAS, the builds are configured via an EAS JSON file and can be triggered via a CLI command. So by default, you have 3 build profiles with the 3 main types of apps you need to build. Let's focus on the local development build. Now, using a CI for local development might sound a bit unusual at first, but given that React Native apps, the majority of development is on the JavaScript side, it actually makes sense. Let me show you what I mean. A React Native app consists of 2 parts: your actual native app with the native code, and the JavaScript bundle with the React application code. In production, the JavaScript bundle is included within your native app bundle. But in development, you typically load this bundle from your local dev server, same as live reloading works on the web. So as long as you haven't changed anything on the native side of your app, this is the iOS and Android folders, you can actually keep using the same native app bundle for development. The Expo Dev Client enables just this. It's a library that adds additional developer tools to the debug build of your app. In addition to launching from your own machine or others on your network, you could open a version of your app running on a dev server on a colleague's machine on another side of the world, or even a build that's hosted on a server. Now that we have our JavaScript bundle sorted, this leaves the actual native app. You can always build this locally, but let me show you how you can do this with EAS. For my Android app, I can trigger a build using the EAS CLI. Since this is the first time I'm building the app, the CLI creates the project for me on expo.dev and asks me if I want to create a key store, the thing needed to sign the builds. Yes, please. My local code then gets uploaded to EAS, and the build kicks off. Once the build is finished, you can immediately install it on a local Android emulator or your plugged-in Android phone. The build artifacts are also stored in the cloud, so you can also install it directly from the website via QR code, which is handy for installing on devices, using Expo Orbit, which makes it easy to install it on simulators, or just download it for any other reasons. In fact, the rest of your team could use the same development build too. The iOS build is similar, only you get prompted to log in to your Apple developer account to generate the signing credentials. Recall how, during development, we use a local dev server to update the JavaScript code on the fly? Well, by a similar mechanism, you can actually update the JavaScript bundle on non-development builds as well, using EAS update. You can create the JavaScript bundle, JavaScript update, which will be downloaded the next time your users open their app. This can be handy for delivering small bug fixes to production, or sharing quick previews during development. On the web, we're used to doing PR previews as part of our workflow. With EAS Update, you can actually create PR preview workflow in your React Native app. Say you're working on the React Conf app and you get a feature request. Could we add a link to the Conf Discord? Sure, that's a great idea, Lauren. Let's do that. So we make the change and raise a PR. With the Expo GitHub action, we can configure the update to be created automatically on each build, and the preview link gets added to the PR automatically as soon as it's built. So we can scan the QR code to open it on your physical phone from the PR, or open it on expo.dev and install it using Expo Orbit. This was the example of opening it on a local Android emulator, and we can do the same thing for your iOS simulator. This makes PR reviews way more palatable and more in line with what we're used to on the web. So far, we've been talking about the development build. Once you're done with development, you'll want to create your production build to share with your users. A production build is actually quite different from a development build. I mean, it doesn't have the dev client for one, but it is also a much more optimized format of your app, and is not even directly installable on your phone. And it also has different signing credentials. With the default EAS config you get out of the box, the development profile is set up to create the build needed for development. And the production profile creates the production build. So really, all you need to do is pass in the production profile to trigger your production build. This build will then be available to download from expo.dev, or you can use another service, EAS Submit, to submit it via CI. With EAS Submit, you can pick a build, either from EAS or from your local machine, and submit it to the app and Play stores. This spins up the submission worker on EAS and uploads your build. So for builds, both local and production, build signing, and deployments, we have EAS. Together, these are the tools that support you in building truly production-ready apps with React Native. Yay! Thank you. So to round off, throughout this presentation, you've heard us mention this React Conf app a few times. We built it to show you an actual real-world example of putting everything abstract that I'm talking about here into practice. It shows you examples of a lot of the things that we'd commonly want to use in your app, many of which are mentioned in this talk. So we have navigation with bottom tabs and modals. We have data persistence. Have you noticed that it works offline? We have haptics, like when you bookmark an item or touch one of the tab bar items. We have animations, like the header scroll on the home page. We have light and dark mode, an animated splash screen, push notifications, an in-app web browser. And we also add some less common but perhaps interesting features, like has anyone found the secret modal? Well, one person has found it. Well, try pressing and holding on your app icon on the home screen, and on iOS, you might find a way to change your app icon. And finally, there's a shout out to probably one of the most awaited releases from day one. It is, of course, using React Compiler. We've just made the repo public on GitHub from now on. So if you're curious to see how everything I talked about fits together, you can check it out. We added instructions on how to build this app on your local machine or via EAS. And now, for the wrap-up, I'll hand it back to Nico. Nico?